An excellent question here from the chapter or from the topic of organic chemistry. So, why is this a very good question? It's because from the very first line, this question will give you curveball. Okay, like see the first thing that you will see over here is this sec-butyl benzoate. Many students don't even know what that is, what the structure of this thing is. Okay, so I'll tell you how to make this particular structure, and I'm very sure this will be helpful for other compounds as well, or like drawing other compounds as well. So we have got sec-butyl benzoate. This word benzoate comes from the word benzoic acid, right? And if you all remember, this is benzoic acid, right? So sec-butyl benzoate is basically removing that H over there, removing that H and adding a sec-butyl group. Yeah, that is sec-butyl benzoate. So now let's start doing things with it. Yeah, I'm sorry, my stylus is malfunctioning sometimes. Okay, now we are adding water and acidulated water, that is H plus H2. When you add H plus in this solution, you see this O has got lone pairs of electrons. It will attack this H plus. Then what will happen? Right? I'm sorry, my drawing is not very good. I hope you are able to understand. So we have this positive charged O over there, which is, as you might know, is not very stable. What will happen now is that this is a good leaving group, a decent leaving group. So this bond here will break, and this will lead to the formation. Let me just draw this outside. Yeah. So what will happen in the very first step is this, and this is benzoic acid, this. Fair enough. Now we have got water, right? Let's write water like this. Water has got lone pairs of electrons here, and this lone pair will attack. So OH2 plus. Now OH2 plus is not a very stable group, so the H will leave and an alcohol will be formed. So the result of the first step is this plus this. Okay, fair enough. All right. So we have got two products here, like we have G and F. Now it says F liberates carbon dioxide with sodium bicarbonate, right? Yeah, it's very obvious. G is this. I'm sorry, is it G? Uh, I'm sorry, F. This is F, right? Because this will release carbon dioxide when sodium bicarbonate reacts with it. And therefore, this is G. All right. So, you know, see, F has got from F, after adding so many products, we are getting M, right? Yeah. So, let's first complete F, complete all the reactions with F. This one should be easy. Okay. So, we are adding ammonia. in the presence of heat. It will form CONH2. When a carboxylic acid reacts with ammonia, it forms CONH2. After that, we have got this very typical Hofmann bromamide reaction. So in Hofmann bromamide reaction, what happens is that CONH2 gets reduced to NH2. You can check the mechanism on internet. It's available everywhere. All right. After that, we have got NaNO2 dilute HCl, cold that is, and water. Now we have to do this some quickly, right? So let's merge both of these steps together. What will happen when NaNO2 plus dilute HCl will react with water? This will form phenol, right? Because in NaNO2 plus dilute HCl, this reaction, it will give an azide, and when this azide will come in contact with H2O, it will give phenol. Very unique, not a unique reaction, but I mean, yeah, this is the reaction. This is M. Very special reaction. You should always remember this. Okay. Try to whenever you see NaNO2 dilute HCl, look at the next step, and you should be able to do both of these steps all at together. That is okay. All right. Let's start working with G now. This is G. G reacts with P. P is given in the option. All right. Let's go with the first option first. SOCl2. A typical chlorination reaction will take place. All right. After that, Mg dry ether. Dry ether. All right. This will be formed. Okay. We can also, matlab, a carboanion will be formed. Okay. All right. And after that, HCHO. This carbanion, not carbanion actually, but this substance which will basically behave like a carbanion. Okay. So this negative charge will attack this carbon center over here. Why? Because this will be this partial negative charge will accumulate uh, in oxygen because it's more electronegative, and C will be more electropositive relative to O. So a partial positive charge will be formed over here, right? So yeah, this will attack the center, and O minus H2, not H2. H over here, H over here. Okay. And and then this thing is treated with H plus. You see, this thing is treated with H plus. H plus. So this H plus will now, this O minus will attack that H plus, and it will basically form this CH2OH. This is R. I'm sorry, this is not R. This is K. This is K, and this is J. No, not J. I suppose this is not J. Yeah, I mean, they are not very important. K is more important for us because this K will now react with phenol, right? K will react with M and H plus. Let's try to make these two guys react. Yeah, phenol. Now, I don't think it makes a lot of sense for two alcohols to react. I mean, I do not know what the answer to this will be. They might react, but I'm very sure none of us know, at least at class, at least with the knowledge which we have accumulated in 11 and 12. I don't think answering this particular question, we can't answer this question basically. I mean, we have got two alcohols and we have got an H plus and delta. We don't know what to do. Okay, so let's leave this option for now. Okay, option A probably is incorrect. Let's see. Let's go for the next options. So I'll make changes over here only. Okay. Okay. So in option B, we have got KBr H2SO4. This is also a bromination reaction. So this chlorine will be replaced by bromine. In the next step, we have got AgC and DMF. What does AgC and DMF do with bromine? It's basically a nucleophilic substitution reaction. Okay, GC and DMF. It's a nucleophilic substitution reaction. All right. Yeah, it will give CN. And when this reacts with H3O plus, it will give a carboxylic acid. Right. Yeah. Now, will this carboxylic acid react with phenol? Yes, it will. This is your very typical esterification reaction, right? I am not going into the mechanism of esterification reaction, but let me tell you a very small trick. How you can figure out the product very easily. Yeah, this is what it looks like. The acid will lose OH, okay, and the alcohol will lose H. So the first product will be water, H2O, plus we are now just going to combine these two. C double bond O. Yeah, I guess that's the product. Yeah, yeah, it is. So this is the product. This is product L. This entire thing over here is L, right? Okay. Now it says L is a metamer of E. What is E? Okay, E is sec-butyl benzoate. Is this a metamer of sec-butyl benzoate? Absolutely. Okay. This is a metamer of sec-butyl benzoate. This is a metamer of E. Absolutely. Okay. So option B is correct. Okay. Let me just go and take option B. Option B is correct. Option A is wrong because I do not know. I mean, I'm very sure I've not found such a reaction in any book as well. It will probably give another something else, not a metamer of E. Okay, all right. Now let's check C and D. If you look at C and D, let's try to do this orally. Okay, PBr3 is a bromination reaction. Mg dry ether, it will make it a carbon ion. Okay, and that carbon ion, when it will attack CO2, see this is what it will look like. When this carbon ion will attack CO2, This is what will happen. Okay. And when you expose it, I mean, when you do this reaction in the presence of in an acidic medium, yep, an acid will be an acid will form. Okay. So the product the product K will be same for B and C, and after that it's the same reaction, right? So C is also the correct answer. C is also the correct answer. All right. Let's go for D. D again, the first step, bromination. Second step will be nucleophilic substitution. The third step will be the uh, hydrolysis of a cyanide. Okay. And yeah, when we hydrolyze a cyanide, we get this acid. Assuming it's complete, okay. Only upon complete hydrolysis do we get COOH. Upon incomplete hydrolysis, I think we get CONH2. I'm not very sure. I need to check. I will check it up. Okay. So again, the final product, not final product, K is the same for B, C, and D. So the final product L will be the same for B, C, D. So B, C, D is the correct answer. There you have it. So this one question will test your knowledge in every chapter, every single chapter of organic chemistry. Okay, starting from the first chapter, that is alkyl chlorides. Okay, it will check your knowledge in the chapter of carboanion, carbocation. It will check your knowledge in the chapter of nitrogen compounds. Okay, so yeah, uh, you can practice these types of questions. There are many such questions in the AITS papers of several coaching centers. Thank you.